What's up, Chem peeps? Who's ready for a free response? A student is investigating the chemical and physical properties and changes of carbon dioxide, CO2. Ooh, it's one of my favorite chemicals. Part A. A student places a piece of solid carbon dioxide into a container and allows it to sublime. In the boxes below, illustrate the carbon dioxide before and after sublimation. Use 6 molecules of carbon dioxide in each box. Represent carbon dioxide molecules as boom. Alright, now this is going to be a little easier for me because I'm going to do some dragging and dropping. First, we've got solid CO2. Boom, there we go. Solid, notice that the particles are all tightly packed together. Then it sublimes. In other words, we go from the solid to the gas phase. Boom, there we go. Gas phase. Particles are spread apart, very far away from one another. Fill in the container. 2 points. Done. Part B. Energy is required to sublimate carbon dioxide. Consider the statement, as carbon dioxide sublimes, energy goes into breaking carbon-oxygen bonds. Is the statement true or false? Justify your answer. The statement is false. Okay, there we have answered the question, but now we need to justify if we want to get that point. Sublimation is a physical change. No bonds are broken in a physical change, and the identity of the material remains the same. Boom. 1 point. Don't forget, it's about the answer and your justification. Part C. The student made a list of intensive physical properties that she observed about solid carbon dioxide. Clearly place a line through the items that do not belong on the list. All right, we're looking for intensive physical properties. Remember, intensive physical properties are properties that stay the same no matter how much of the material you have. So white color, that belongs there. Mass, 5.20 grams. That's an extensive property, so I'm going to draw a line through that. The mass is going to change depending on how much of the material you have. Whereas the color, for example, is going to stay the same no matter how much of it you have. Odorless, again, that's going to stay the same. No matter how much CO2 you have, it's going to be odorless. Brittle, also going to stay the same. No matter how much of that solid CO2 you have, it's going to be brittle. Sublimes at negative 78.5 degrees Celsius. Also an intensive physical property. No matter how much CO2 you have, it's always going to sublime at negative 78.5 degrees Celsius. So the only item on that list that doesn't belong is the mass. Mass is extensive. It changes depending on how much of the material you have. All right, now we're told that a student performed a laboratory experiment to determine the density of carbon dioxide gas at room temperature. The steps below outline her procedure. Assume the balloon is perfectly spherical, that carbon dioxide is the only gas inside the balloon, and that no carbon dioxide escapes once the balloon has been filled. You're provided with a series of steps for the procedure. Step 1, determine mass of empty balloon. Step 2, fill the balloon with carbon dioxide gas. Step 3, use a string to determine the circumference of the balloon. Step 4, from the circumference determined in step 3, calculate the volume of gas in the balloon. Step 5, determine mass of balloon filled with carbon dioxide gas. The data table below summarizes the information collected by the student throughout the lab. Part D, calculate the following. Subpart I. What is the mass of the carbon dioxide collected? Mass CO2. This is going to be equal to the mass of the balloon filled with CO2 minus the mass of the empty balloon. Let's hit up our calculator. 4.54 minus 2.70. Keep sig figs in mind, 1.84 grams of CO2. Boom. Subpart II. What is the density of the carbon dioxide gas? Answer in units of grams per cubic centimeter. So units are also super important on the free response, especially so when they call them out to you in the question like that. Density is equal to mass over volume. We just determined the mass of our carbon dioxide to be 1.84 grams. As I scan my data table, I notice that I'm given a volume of the carbon dioxide gas, but notice that we're given the volume in liters. So I'm going to convert my 1.00 liters first to milliliters. 1,000 milliliters is 1 liter. Then remember this important relationship between cubic centimeters and milliliters. They're the same. In other words, for every 1 cubic centimeter, I have 1 milliliter. So 1 times 1,000 times 1, 1,000 cubic centimeters. So I'll throw that into my density calculation here. Jump to my calculator. I get 1.84 times 10 to the minus 3 grams per cubic centimeter. Box that sucker in. Boom. All right, that brings us to part E. It says when determining the circumference of the balloon, the student compresses the balloon so the measured circumference and therefore the calculated volume of the balloon is smaller than its actual value. Would the calculated density of the carbon dioxide increase, decrease, or remain the same? Mathematically justify your answer. Okay, let's think about the formula for density. It's equal to mass over volume. Now, if we were to manipulate the variable so that volume decreased, the mass would stay the same, our density would increase because we're dividing by a value that is smaller, or the value in our denominator is much smaller now. So, the calculated density of CO2 would increase. A smaller measured circumference would result in a smaller measured volume of CO2 and therefore increase the density. Boom. All right, and that brings us to part F. We're finally there. It says the density of air is 1.2 times 10 to the minus 3 grams per cubic centimeter. Would a bubble of carbon dioxide float or sink in air? Explain. Assume the bubble has no effect on the density of carbon dioxide. Again, in these problems, you're often going to use earlier parts of the problem to answer the question you're working on. We solve for the density of carbon dioxide gas to be 1.84 times 10 to the minus 3 grams per cubic centimeter, CO2. Air has a density of 1.2 times 10 to the minus 3 grams per cubic centimeter. Density of CO2 is greater than the density of air. The bubble of CO2 will sink because CO2 is more dense than air. Boom! And we are done.